respected Professor Dipti Patra, HOD Electrical Engineering and Chairperson, Institute's Gati team, respected Professor Iti Saha Mishra, Chair-elect IEEE Kolkata section, respected Professor Kamalakanta Mahapatra, Chair IEEE Rourkela subsection, respected Ms. Rashmi Varma, President and CTO, Innovate 5G Inc., US. Today is a very auspicious day, Dola Purnima. I heartily welcome all participants, faculty colleagues, and our students to this inaugural function. At the outset, I would like to present an overview of this webinar. As you know, the forecast for future 10 years traffic demand shows an increase in 1,000 scales and more than 100 billion connections of Internet of Things, which will impose a big challenge for future mobile communication technology beyond the year 2020. The mobile industry is struggling in the challenges of high capacity demand but low cost for future mobile networks when it starts to enable a connected mobile world. 5G is targeted to shed light on these contradictory demands towards year 2020 and beyond. Further, mobile broadband service disrupted the traditional business model of mobile communication, enabling unprecedented user experience and making a profound impact on every aspect of people's work and life. It will be a new standard that not only provides a huge data rate of some Tbps and extremely low delay of 0.1 milliseconds latency, but also massive IoT will enable the hyper-connected paradigm that will connect user with things. So, looking at this transition in technologies, we have chosen to organize a webinar for sharing knowledge and expertise of distinguished wellness communication professionals from academia and industry together on a single platform. This program has been made aligned with the vision of DST Gati scheme for encouraging participation of women professionals as the webinar is being sponsored by this scheme. As we have planned lectures in many emerging topics like 5G new radio concepts, cognitive radio, millimeter wave MIMO communication, terahertz communication, ultra reliability low latency communication, edge computing, and network sustainability will be delivered in this 5 days period. I am happy to share with you that we have received a very good response from academia as well as industries. More than 50% almost are from outside of NIT Rourkela, and we have industry participants also. We hope this 5 days long webinar will give an exposure on cutting edge research as well as technological advances in the field of wireless communication to all participating faculties, students, research scholars, and industry professionals. This webinar is technically sponsored by IEEE Kolkata section and promoted by IEEE Rourkela subsection. This has helped us immensely to reach out to our professional community. Now, I would like to invite Professor Dipti Patra, HOD, Electrical Engineering and Chairperson of Institute's Gati team to address. Dipti Madam, please.
Thank you, Susmita Madam. Esteemed dignitaries, our Honorable Director, Sir, Professor Karnam Uma Maheshwar Rao, Professor Kamalakanta Mahapatra, Chair IEEE Rourkela Subsection, Professor Iti Saha Misra, Chair-elect IEEE Kolkata Section, Ms. Rashmi Varma, President and CTO, Innovate 5G Inc., my faculty coordinators, Professor Susmita Das and Professor Suman Kumar De, dear participants from industry and academia, students and other invitees. It is really a pleasure and honor for me to welcome all of you to this webinar. It's a 5 days webinar and it's sponsored by Gati NIT Rourkela, Gender Advancement for Transforming Institutions. It's a overwhelming day for me because I am acting as HOD of the Department of Electrical Engineering, and it's a proud moment for me because my faculty colleagues are organizing a seminar, and that is on a very futuristic topic. And the name of the topic is Emerging Wireless Technologies Connecting the Future. And it's a really pride moment that all the speakers are women. All eminent speakers are women from all fraternity, starting from all the highly, actually the academia like IITs, NITs, and also from industry like ISRO, and from this CTO, the Innovate 5G Inc. So many eminent speakers we are finding in this webinar to share their expertise and knowledge. So it's a pride moment for me and also for the participants. Let me brief about my department. The Department of Electrical Engineering was established in 1961, because it's one of the major departments and a premier department in NIT. Since its inception, the department is under dynamic progress, and it is reputed for its imparting quality education both in undergraduate, postgraduate, and PhD level. The department has 4 research groups: communication and signal processing, power system engineering, then control and automation, and power electronics and machine drives. Our undergraduate and postgraduate students, as well as we have significant number of research scholars, they are working on diversified areas of electrical sciences towards the award of their PhD degree. We also have started with minor degree program, and as per institute norm, we also started executive PhD program. The academic and research activities in the department focus on the frontier areas, that is power quality studies, distributed generation, then soft switching conversion, inverter design, control strategies for complex dynamics, then network control systems, high voltage and insulation systems. So various fields are there. And along with that, we also have the topics on signal and image processing, communication systems, machine learning, and energy storage system. The department hosts 2 centers of excellences. One is renewable energy system and another in industrial electronics and robotics, with participating faculties from other departments to boost the interdisciplinary research. We also have recently DST, IIT Bombay collaborated energy storage platform on hydrogen. We also have some research labs, just like your semiconductor processing lab, nonlinear dynamics, electric vehicle, and these labs are funded by various funding agencies like DRDO, ISRO, IMPRINT, DST, CDAC, CSIR, SERB, MHRD, BRNS, METI. So number of sponsored research projects also we have. And recently the department has collaborative research program with internationally acclaimed universities also. And we are always conducting various workshops, quality improvement programs, seminars, GYAN courses, to always acclimatized with the current technologies and cutting edge technologies. So it is always a pride moment for me when my faculty members, they always come forward to share their knowledge, uh, to conduct something and provide a lot of platform to other people so that they will be benefited. Now coming to, let me introduce to also the Gati program. Just a minute. Gati, as I told you, that full form is the Gender Advancement for Transforming Institutions, and it was conceptualized by Vice Kiran Division of DST, that is Department of Science and Technology, Government of India. And this program was launched by Honorable President of India as part of National Science Day on 28 February 2020. And NIT Rourkela is selected out of 180 institutions that had applied to be part of the initiative and will execute the project along with 29 other institutions in the country. That means the competition was too tough and NIT Rourkela could beg that proposal. So in particular, Gati aspires to create an enabling environment for equal participation of women in science, technology, engineering, medicine, and mathematics, that is STEM, at all levels with the idea of promoting the upliftment of women. So the project was formally commissioned to NIT Rourkela in August 2021, and now we are ready for its execution. So as a Gati self-assessment team chairperson, we have conducted 7 webinars. So this is the last webinar, 7th webinar, which is funded by Gati in this financial year. And it is really a proud moment that within 4 or 5 months, we could encourage so many women faculty members, and they could organize 7 webinars in short duration, and where most of the speakers were also women. And also Gati had initiated many other programs. We also celebrated Women's Day in a underprivileged village, in a remote village for underprivileged women and adolescent girls. We did some awareness program. So on behalf of Gati and Department of Electrical Engineering, I again welcome all of you to this wonderful evening, and it is the starting day of the webinar, and I congratulate both the coordinators for, and I also expect that all the participants will enjoy this 5-day webinar. Thank you very much.
Thank you, madam, for your motivating speech and enlightening the audience about the work by Gati Institute's Gati team. It's a very inspiring speech for all of us. Thank you again. Thank you, madam. Today, we are honored to have our esteemed director, Professor Karnam Uma Maheshwara Rao, as the chief guest of this evening. Let me read the brief biodata of Professor Rao. Professor Rao has graduated in mining engineering from Osmania University, Hyderabad in the year 1983. After working in various mining industries for a total period of around 3 years, he joined Indian Institute of Technology, Banaras Hindu University for a Master's in Engineering program. He acquired his M.Tech in mining engineering in the year 1987. Professor Rao started his teaching career as a lecturer in mining engineering at the then Regional Engineering College, Suratkal, Karnataka during 87 to 89. Later, in the year 1989, he joined Indian Institute of Technology, Kharagpur in the Department of Mining Engineering as a lecturer. He obtained his PhD in the field of rock mechanics from IIT Kharagpur. With a steady growth from lecturer, he became a full professor in the year 2004. As a professor, Dr. Rao has served IIT Kharagpur at various administrative positions. Some of the important portfolios were as the chairman is state, vice chairman joint entrance exam JEE. Professor Rao was the head of mining engineering department during the year 2006 to 8 and again in 2010 to 14. Professor Rao has worked as postdoc in Korea Institute of Geoscience and Mineral Resources during the year 2003 to 4. Later, he was also awarded erudite fellowship from Kigam, South Korea in the year 2005, and Professor Rao was appointed as a visiting professor at the Chonam National University CNU, Guangzhou, South Korea in the year 2008. He has served as a professor in the Department Energy Resources Engineering at CNU during the year 2008 to 9. Further, during his association with South Korea until the year 2012, he was invited on various occasions for delivering lectures in the Seoul National University, Cheonnam National University, Gangwon National University. He was also invited by the University of Adelaide, Australia for delivering various lectures in mining engineering. Later in the year 2015, he was appointed as a visiting professor in the University of British Columbia, UBC, Okanagan campus by the School of Mechanical Engineering. So today it's a great privilege and honor in my part as coordinator of this webinar to invite our director sir to address and inaugurate this webinar. Sir, please.
Thank you very much, Professor Shushmita Das, and all the other dignitaries online. Professor Deepti Patra, HOD, Electrical Engineering and Chairperson Institute's Gati team, Professor Iti Saha Mishra, Chair Elect IEEE Kolkata Section, Professor Kamalakanta Mahapatra, Chair IEEE Rourkela Subsection, and Madam Rashmi Varma, President CTO Innovative 5G Incorporation USA, and other faculty members of my institution, students, and other research scholars. It's a great privilege for me to be present here today, and whatever the position I'm really being invited, right? It gives me immense pleasure to be participating here on the webinar, 5-day webinar on emerging wireless technologies, connecting the future, organized by the Department of Electrical Engineering, NIT Rourkela. I think we have already entered that particular future where the wireless communication system becomes really very important. And to add to that one, COVID has in fact given an opportunity for this particular technology to take an important role. And indeed, I think there is no exaggeration in stating that students from KG class to PG and across the various people in the society have enjoyed or rather been connected to the various activities through internet and then various other facilities on communication systems. There is absolutely no second thought about its effectiveness in trying to keep the system working, system functioning, and system connecting to the people and then technology. And industry, as far as industry is concerned, industry has already entered into 4.0 revolution, whereas the communication system has already entered into 5G and then it is further going into 6G. And as you all have witnessed that Industry 4.0 revolution has given way for various applications of communication systems like the IoTs, machine learning, big data analysis, artificial intelligence, neural networks, and augmented reality, and whatnot. The chain of the applications is really increasing at large. And at this particular time, this emerging wireless technologies, I don't really have to, again, re-emphasize its applications and then its utility, and then its dependence today, and then the dependence on it for the future generations. The one aspect which we all have to really realize is that this is a wide spectrum of its utilization and the energy consumption and then the cost. These are the three various prime parameters which makes this technology very convenient and comfortable for its percolation into every the person of the society. And having said that one, right, and then I take this opportunity further, though it is too late, belated the congratulations on the eve of the International Women's Day. I am really thrilled to see that the most of these speakers on this day are the prominent speakers are women across the country. And then I wish you all the very best and the success. And you are already empowered to the extent that now you are leading from the front and in various the spectrums of the society. I'm happy to know that many emerging topics will be delivered by the distinguished speakers in this field, and I hope that this 5-day long webinar will give an exposure on the technology advances and in the field of wireless communications to all participating faculties, students, research scholars, and industry professionals. My only rather concern here is that technology is there, network is there, but then there are too many network towers today in every city. That's where the intersection or the interference of one tower with the other one, and then there is a great slump in the connectivity. I'll just give my personal experience that I live in a small place in Hyderabad where my flats has 3 towers. One is the Geo tower, another is the Airtel tower, as well as BSNL tower. And I really do not know. Then many people have visited my house, and then we cannot have the internet connection in my house. It's a first floor. I do not have the internet connection, nor I can really communicate to anyone in this era where 5G is already there, right? If anybody is trying to call me, I just cannot receive the call and I have to run out of my house. And to add to that one, people will be surprised. It's not a surprise. It's a challenge to all the technocrats out here working on wireless technologies that I have got to keep running to the point. There is only one small shadow area where I get the connection, right? And only I have to really stand there and then work on that particular shadow area. So now people from BSNL have come, people from various other connectivities have come. They have put the boosters, whatnot, everything. But then again, me running from the house is still there. So now I think with so many the provisions that we have today on the cities, like Geo is there, Airtel is there, and then BSNL is there. Everybody is trying to advance their wireless communications. I think there should be some mechanism by which there is no interference of one signal with the other, and the customer is the right at the advantageous position. With these few words, I congratulate once again the eminent the women speakers and the prominent positions that you have taken today, and then see that this the wireless communication system is really become very successful and sustainable. And today, right, I think life without wireless communication system, it is impossible to think about. And then wish you once again all the very best, and it gives me immense pleasure to be present here, and wish you all a happy Holi. Right? Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Yes, thank you, sir. Again, happy Holi to you all.
Yeah,
Again,
thank you.
Thank you, sir. Thank you, sir, for sparing your valuable time with us in this evening, and you really gave us an inspiring speech, and by also exposed us to practical challenges existing due to the interference, which is a major concern for the user point of view. Yes. And research is working on, people are working on how to reduce that interference effect, definitely.
Susmita madam's research students, they work on this problem only. How to
Yes, sir.
mitigate the interference.
This is one of my research area also, sir.
Maybe I need your help, madam, because otherwise I become one day I become a sprint runner just to catch the signal. Right, I'm getting old, and so I do not want to run out of my home, and I want to stay home and enjoy the network facilities. Right, madam.
Thank you so much, sir. Thank you so much, sir. Uh, Now I would request one of our most senior most professor of electronics and communication engineering department, Professor Kamalakanta Mohapatra, who is also the chair IEEE Rourkela subsection, to address this audience. Thank you, sir. Please, sir.
Thank you, Professor Susmita, and respected dignitaries, respected Professor Rao, Madam Tisa Misra, Madam Rashmi Varma, and Professor Dipti Pat, Electrical, and the coordinators, Professor Susmita Das and Professor Suman De. This is a very absolutely contemporary topic which Susmita has taken up. I call her Susmita, please don't mind. She was my student one day. So, essentially, such a topic, while they are essentially focusing on two paths, on the traffic load and latency. But as Rao sir pointed out, a typical very scenario that is happening, and that is all has happens. So it's a big challenge, but simultaneously, I won't say that it cannot be solved, because while communication, although I am not a communication specialist, but for all my IoT and embedded technology and industry 4.0, I have to use communications. I don't have an escape from that. And while doing that, the biggest challenge to me is looking how the communication is established in a noisy channel. And that's the problem Professor Rao said, and we would normally say this is a noisy channel, and that is what you have to look at, and more of interlevers and kind of things. And if somebody says that, why don't you work on interlevers, then I say that I would love to develop an FPGA-based development board, or developing an IC for that, or looking at the low power technologies, but not exactly interlevers. So anyway, that's the point. There is a lot of interesting topics because this is an absolutely contemporary topic, and let us hope good things do happen. And coming to the fact that this is being sponsored by Gati, where Professor Dipti Patra is the chair as far as our institute is concerned, they are doing pretty well. When I remember when I was absolutely new in this, that time it was a college, RE college. Today we are in institute. We had only two madams in our whole institute. Madam Pramila Panda in humanities and Madam KL Roy in mathematics. But today we have a huge percentage. I mean, it's a good percentage. Those days Dipti was our student in electrical engineering department. And now all of them have become professors, HODs, deans, and all that. So also Avanti, Susmita, and another Susmita in chemical, and all of them. So it's good that the progress has been absolutely fantastic. And what is the wonderful thing that as far as Gati is concerned is that I find that in today also the list of speakers, the majority, I don't know whether it is 100%, but at least absolute majority looks female speakers. It is nice to have Madam Itisa Misra over here also. She is chair-elect from IEEE Kolkata section, and there is another madam. She is not today present, but she is also chairman of Kolkata section. So the females are doing pretty well. And then we have Madam Rashmi Varma, who I found that she is the only one who responded to Susmita's mail immediately after. So that is why when I checked out my mailbox, I found Rashmi Varma's mail. Then I found something, but I lost the link because it was in the original mail, and then the other mail is coming in the overlap. So today I bothered Susmita again asking that, where is that? She said, no, I sent it yesterday evening. Then I said that, yes, I understand then. Oh, then I go back to the previous one to find it out. So pretty interesting. And so the things are happening very well. As regards to IEEE front, because Madam Miss Itisa Misra is there, we are a new subsection, only 1 year old, and with 83 members, and out of which 22 are senior members. But we have 50 graduate members and members. So we try to plan a lot of things with good wishes, blessings, and best wishes from Kolkata section. So I hope Madam Itisa Misra would support us in all our endeavors. So till now, we have been doing online stuffs. Hopefully, IEEE will also have its own activities offline shortly, expecting that the coronavirus goes away from us. And let's hope for the best. I hope all the participants, because there are some of the in-house participants, but a lot of outside participants. I hope it would be a lot of educative for all of them. And we hope to plan all these programs under IEEE banner. And let us hope for a good 5 days, because it's supposed to start from tomorrow. But as tomorrow is Holi, obviously they are starting it today evening. Let's have a nice time, and let us, I request all the participants to be more active while participation goes on. And so that would actually bring a lot of interest rather than becoming passive listeners. Let us hope with all our brainstorming and all the lectures and everything going on, we hope to bring good things to our nation. Thank you, everybody, and wish all of you a very, very happy Holi.
Thank you, Professor Mahapatra, for your nice and interesting speech. Today we have amongst us the chair-elect of IEEE Kolkata section and a senior professor of Jadavpur University, Kolkata, Professor Iti Saha Mishra, who has always been a great support for organizing such technical events. Madam Mishra, I request you to address now.
Okay, I'm very sorry that my video is not on, but I think
madam.
you do hear all
Yes,
me?
madam. We are able to hear you.
Okay.
Please speak.
Respected Professor Rao, Director, NIT Rourkela, Professor Dipti Patro, Shushmita Das, Professor Mahapatro, respected Rashmi Varma, other dignitaries, participants. A very good evening to all of you. I am very much delighted to be the part of 5 days webinar on the inaugural section on emerging wireless technologies connecting the future with the support of DST Gati under Voice Kiran, and the program is technically co-sponsored by IEEE Kolkata section. I wish you all a very happy Holi. May the color of spring bring joy and happiness in everybody's life. May the light Kiran reflect the glory of women in science and engineering. May the bondage break and enlighten the inner strength of every woman engineer for their progress. I am Professor Itisha Misra, participating on behalf of IEEE Kolkata section from a position of chair elect. I have an intense relationship with NIT Rourkela through Shushmita, Dipti Madam, everybody, and I am always with there for every IEEE related program, and will be supporting in future also. IEEE Kolkata section established in the year 1971 as a subsection with the entire eastern and northeastern member under the chair Professor late Alok Kumar Ghosh. Then it promoted to regional subsection under IEEE Delhi section. With the commendable efforts of Mr. K.B. Subramaniam and Mr. K.K. Dasgupta, the Calcutta subsection was raised to the status of a full section on September 28, 1978. At first, Kharagpur IIT was the subsection under Kolkata section. Then it is upgraded to a separate section under the Midnapur domain. today we have 5 subsections: Bhubaneswar, Rourkela, Patna, Guwahati, and NIT Silchar. Okay, and the dimension of IEEE Kolkata section is increasing day by day. It was earlier, the name of the Kolkata section was Calcutta section. On 2011, as per the Bengali convention, the name has transferred from Calcutta to Kolkata. Okay, now there are several, we are very happy by observing the various society chapters. We have 17 society chapters, affinity groups, 3 WUI affinity groups, young professional affinity group, site affinity group, and also the student branch, more than 170, student branch chapter, more than 130. So all the, though they are not all active in their activities, but I hope I must encourage the student branch to be active in the IEEE domain and must enroll with the progress development of the present day technologies and realize the IEEE mission and vision. Okay, so I must thank Professor Sushmita Das for inviting me, and also Professor Shumon, the organizing part of this event under WISE. Our lives is revolving through wireless technology nowadays. I could see its evolution as I am growing from the years of 1970s to the present day. The boom of 5G technology and Internet of Things are changing the scenarios. Technologists think that 5G and IoT would be a game changer for our life. It will provide faster communication from self-driving vehicles to smart grids, for renewable energy to AI-enabled robots on factory floors, etc., etc. So imagine a situation, the day will come where chronic health conditions like diabetes and heart health are managed 24/7 days without the real hospitalization of a patient from the home, and maybe properly take care in time to prevent their death, in-time death, and where smart homes unlock doors with a face scan and then automatically adjust lighting, temperature, and even order groceries for delivery before one can reach to the home, okay, and run out of the milk suddenly, and control the home smart TV, smart fridge, etc. outside of the room through the IoT and 5G applications. So these are the technology scenario that will change another steps and move forward with the participation of the machine-to-machine device communication, with the integration of 5G, and people are talking about the 6G. But Professor Rao, the director, has really pointed out a practical situation. I think the situation is not very difficult. If everybody trying to see or find out the real problem, what is happening, I think that if there is a problem, there will be a solution. So solution will come one day. So this is a very great event. I wish the great success of the 5-day webinar. Let the participant gain knowledge and aptly apply in the research domain and contribution and progress in their future endeavor. I thank you, all of you. Wish you a very happy Holi. Thank you all.
Thank you, madam, for your
okay, Shushmita
nice
madam, I
speech.
have to leave for another program.
Okay,
I was waiting. Okay,
it's all right, madam.
Please excuse me, all of you.
Thank you so much.
Okay.
Thank you so much for joining in this evening.
Thank you, madam. Thank you.
Okay, thank you.
So let us proceed for the next. Today, we are very much fortunate to have Ms. Rashmi Varma as our keynote speaker. Ms. Rashmi Varma is currently the President and CTO, Innovate 5G Inc. US. She has led the way for women in telecommunications since 1997. She has experience in both optical and wireless communication together with embedded software design, research, and development. She envisions bold and cutting-edge innovative ideas and leads multidisciplinary product teams across the globe with an unwavering focus to exceed customer expectations. In 2016, she was among 25 honorees selected as the top woman in technology in North Texas, US. Since then, she has launched several startups and is currently building Innovate 5G Inc., which is targeted at building the first telco application performance monitoring APM platform that allows groundbreaking 5G applications to emerge in the market. So we are very much obliged to you, madam, for accepting our invitation in a short notice and speaking in this morning hours from US. I request now, madam, to deliver your talk on sustainable power consumption in 5G networks. This is the keynote talk she is going to deliver now. Madam Varma.
Thank you, Professor Das.
Please.
And so before I begin, I want to take the opportunity and say thank you for this invitation. Actually, the pleasure was mine to receive an invitation from you all. And it is very, very, very nice to see Gati, a program like Gati, and seeing Professor Patra, Professor Das, and listening to Professor Rao and Professor Mahapatra. Thank you, Professor Day. This is an amazing opportunity for me to be present and be able to contribute towards your seminar in my way of giving back. I am originally from India. I was born and brought up in India, and I came to the US in 1998. So even though I've been here for a long time, I feel my roots are still connected back to India. And this was so when I got your invitation, I felt this was amazing that I could actually now contribute back to my home country where I can see all this work is going on. And so it's amazing to see that a program like Gati is in place. So I said I must participate. Doesn't matter what time of the morning it is. So thank you for this opportunity. Let me share my screen so I can bring up my PowerPoint slide that I prepared. Are you able to see my screen?
Yes, madam.
Okay,
Yes,
thank
ma'am.
you. Thank you. So one thing I would like to, so the way I look at it, I have been in this industry since 97. I started in India with a company called Facil, which is now owned by Vodafone in the wireless communication field. Back then, that was GSM. And, it was a Star Trek moment for us to see these phones. They were pretty big back then, that we could walk around without a cord attached to it. And I was very enamored by that. The other thing that happened was the internet came into India, and people were on Hotmail back then, I remember. And it seemed like, how does this, so the question was, how does all this work? How are these computers communicating? How are these phones connecting? And that's when I started studying, SS7 signaling layers, OSI signaling layers. I was just graduating out of college, and 97, my final internship was at Facil. So to now learn more about how computers communicate, I decided to come to the US to do my master's in computer protocol design. And my focus was mainly the protocols that are used for two computer nodes to be able to communicate with each other. And since then, I have been I have had the opportunity and I'm very grateful that I've had the good fortune to be working in areas like optical networks, and specifically working on high-speed backbone networks. Back then, we started out with very low speeds. Now that seems like a long time ago, and we used to work on OC3, OC12, OC192. I mean, anyone in the audience who has an optical background can understand like what those data rates are. I was part of the team that built the first 10G interface. I was also part of the team that built the first photonics 40G interface. And now today we know, there is 400G interface cards, line cards, now coming up to 800G, which obviously in the optical world, these are mind-blowing, blazing fast speeds. And today, in fact, the optical is not just used for the backbone networks. It is also used for front haul and backhaul in the wireless networks itself, because wireless networks themselves are producing so much data that they need efficient ways to connect the radio sites to the core part of the network. And now optical fiber is part of the wireless network. So what I started on 97, I decided to actually come back now in the space of 5G and work on wireless one more time. And I have been amazed by how this technology has moved. And so it's and that's why I wanted to come in and do something in the 5G space. We all know that the communication networks, of course, are the main pipelines, and they're today critical infrastructure for most countries. In fact, the governments have strategies and initiatives and policies for communication networks today. Here in the United States, that's managed by the FCC, the Federal Communication Commission. And as far as 5G is concerned, it has become a national. It's a matter of national importance, especially where America is going head on head with China, and of course, China is leading this competition in 5G way ahead of North America. And so the main drivers of a communication technology, it's not about putting in communication networks. It's about who is using these communication networks. So, and today we know, without wireless networks, we cannot perceive a life on this planet where we feel we do not have the, if we are looking at air to breathe, water to drink, and food to eat, we need wireless networks to exist, be able to communicate, not only communicate socially, but interact business transactions. Our social economic lives depend on it. Our commercial GDPs depend on communication networks. So it's of utmost importance. And however, it is the applications we believe that basically drive these networks. And so the, new technology, when it comes in, creation of it, building of the technology, and the proliferation of technology, that's all great. A lot of money is spent. A lot of policies are built around those. However, the main thing about the technology is the adoption, and the adoption comes from users like you and me. And where the adoption comes in, it is the applications that make the biggest difference. So we can see that, as we came through 2G, 3G to 4G, we can say that, with 2G, of course, we could make wireless phone calls. With 3G, we brought the web browser to the user on their phones. And you were able to go on to, you could do your web browsing, you could watch, you could actually watch certain amount of content on it. But the moment the applications pushed past a certain data rate, for instance, when YouTube came around, video streaming, and when social media came around, Facebooks and the Twitters of the world, we were actually lacking the data speed. So from 3G we went into, we actually created a data portion of 3G where we implemented database applications. Now coming into 4G, we have stepped into a shared economy where companies like Uber and companies like Airbnb operate these applications that basically use these networks. So in a way, if you notice, every time we've come into the age of connectivity, with it has come the opportunity to do something different that hasn't been done before. And it's the applications that basically drive the usage of the networks and how a network is phased out, going to 5G, going to 6G, is the demands from the user base that causes the technology to move. And of course, the esteemed faculty at NIT and many other universities are very busy with research work that goes on in these areas, specifically with building these networks. And so my topic today is slightly different from the regular work that I do, which is the application testing on 5G networks. Innovate 5G is actually the first company to have made a first 5G standalone call in North America in the mid-band spectrum. So we have our own 5G network testbed here in Richardson, Texas, where last year on July 21st, we actually came ahead of Ericsson by a month and a half when the mid-band spectrum has opened up. We were the first. We were the first lab to make a 5G standalone call on it, and we claimed that spot for ourselves. And so it was a proud moment. But in building that lab and building some other networks that we have done in the field, I have come upon this interesting problem of power consumption, which I feel today possibly we don't have the best solutions. But I wanted to bring this to this group, and of course, it is a big challenge for me to bring a topic to such an esteemed group, because you are already in cutting edge research work. And I was a little concerned. I was like, how do I shine a light on something that is because you guys are working at a level that the industry is possibly not even there yet. But I wanted to bring this problem statement. So I said I should probably focus on bringing a problem statement that needs more research and more work to be conducted. And possibly that's a good way to discuss how to eliminate this issue. And I also feel that not many people are aware of this problem. I know everyone in the industry is talking about 5G, 6G, and even 7G. However, power consumption, power in our society, power is again very similar to water, air, food, and communication networks. Everyone needs power in their homes. Power is needed to power basically the grids power everything in a city, an urban city, rural areas, your agriculture, everything utilizes power. However, our demands on power are increasing exponentially, and the kind of decisions we make to, especially even to make these communication networks, power becomes a very important component here. So with your permission, I will begin. And yeah, so we know about LTE power, and I know it's so today we actually look at radio sites. The biggest component of wireless communication networks is radio locations, radio towers, where you will notice the antenna is there on the top, but much of that equipment is at the bottom of the tower. And when Professor Rao was talking about running out of his home with the tower on the top and trying to find an area where he can make a phone call, I hope he doesn't have to stand on one leg to do it. But as long as he runs out and finds a spot where the coverage is available. However, there is already constraints on power where when these towers are built. we can see that we need approximately 150 watts to even power up a 20-watt antenna. The electronics of everything that goes into a tower needs approximately 50 watts. The major power consumption is on the cooling. And we also require heating sometimes in the Nordic countries where it's very cold, Canada, Alaska, places here in the United States that are north of Texas. We are very fortunate to have good weather here in Dallas, Texas. However, north of here, it gets very cold very fast. So heating is also a requirement for some of these tower sites. So overall, if you look at it, if I look at a one transmit receive chain for a wireless, for a radio site, I'm approximately consuming about 500 watts on that on that radio site. Now, of course, we have several sectors that we build into these radio sites. In average site would mostly have 3 sectors. You can say that they might have 2x2 Mimo antennas on there. And for those that don't come from an electrical engineering background, these are antenna technologies that have been put into place to create a better signal propagation. So that, as what Professor Rao was mentioning, sometimes the signals are not working. There's a lot of work going on in creating better signal propagation, canceling interference through antenna technology. And massive MIMO is something that's used in 5G. MIMO is a technology that's used in 4G today. So 2x2 MIMO, you would have 2 carriers on a radio site. There are radio sites that have 1 carrier that also works, but you can look at an average radio site as having 2 carriers with a 20 megahertz frequency band. That means whatever we calculated here, 500 watts, that's basically 12 times 500 watts is what we need to power a radio site with this kind of technical specification, which would bring us to this number. That means per radio site, my total power consumption is about 6 kilowatts. And if I look at, of course, I mean, when you're sitting there, you're like 6 kilowatts. I have no clue what that really means or how much that really is. We can look at it in terms of a square kilometer of covered area. We can say that for every square kilometer of covered area, based on this calculation, we need about 0.4 kilowatts of power. So Professor Rao is under those antennas, and the moment he runs out towards the front of this house, wherever he gets coverage, there for every square kilometer of the coverage, we need about 0.4 kilowatts. So now the numbers that I showed you, I want to just see if there are any questions on that slide that I can answer, that I may be able to answer here. I know Professor Mahapatra wanted this to be a little interactive. So if anyone has any questions on this.
So please, if anyone have any questions on that, raise your hand so then I can unmute you. Unmute you. Please.
Okay, so to put that into perspective, I wanted to bring this slide, which is very important. Here you can see 2G, 3G. We were consuming around about 4.8 kilowatts is the number here. We went with a small increase when we introduced 4G, so about 43% higher to about the 6 kilowatt calculation I came up with. So that's approximately about 6.8 kilowatts, right? But do you notice that going from 4G to 5G, there's a 68% increase? That this number has almost doubled in terms of power consumption. That means what we need to what we need to power a 5G radio site is approximately 11.5 kilowatts, which is a huge jump coming from even 3G to 5G, or 3G to 4G to 5G. And that's basically what it is. It's doubling the power consumption from the radio sites. So this is a big moment of truth. And you will not hear a lot of people in the industry talk about this, because everyone from the OEMs to the operators are basically busy in trying to position 5G technology so that we can move forward. And the biggest advantage of 5G, of course, is data rates, correct? As the date, because we know that we have to improve our data rates today, because the applications coming in today, 4G is not able to keep up with the data rates demanded by those applications. Now we have Netflix coming in, when now people are streaming Netflix videos over a 4G network. But now Netflix has launched 4K videos. Tomorrow, in the near future, they are going to launch 8K videos. And not just Netflix, there are many such similar services that are now going towards ultra high definition. And as Professor Rao was talking about augmented reality and so on and so forth, what we are going towards is more immersive definition. So we were at high definition HD. We are now going towards ultra high definition 4K, 8K videos. And tomorrow we are going towards immersive definition, where we will be able to interact with the content using a HoloLens or a virtual reality lens, augmented reality goggles. That kind of a content would be available. However, we are running out of steam on our current networks where we can service those applications. And Miss Iti actually mentioned doing heart rate, basically health monitoring, diabetes monitoring, 24/7. Imagine having to run out like Professor Rao to make sure your pacemaker was running. So we do know that we have to proceed towards 5G, and most of the industry focus is in pushing the technology out, commercializing the networks. However, this is a moment of truth where we are requiring twice the amount of power. Today, the world is already experiencing power shortage, and I'm sure in India more so than what we have here in North America. In fact, we here in Texas, we were in the news all over the world when in March 2021, the entire state lost power. We had no power, no water, no heating in our homes for 3 days, because we were hit by a freeze that Texas had never experienced before. And so our grid and our turbines were not equipped to handle freezing temperatures. So the entire power plants, all power plants across the state had to shut down because of that. Now, communication networks were down, of course, no internet for 3 days. I think that's when you really find out what is the impact of not having adequate power in your life is. And now we are putting a great demand on that power grid and these grids actually are not made for networks to come in and double their consumption. The one fact about 5G remains that we know a lot of 5G networks are being implemented as millimeter wave networks, which means the coverage doesn't go that far compared to 3G, compared to low band spectrum or even mid band spectrum, where 3G and 4G networks were deployed earlier. We need more radio sites for 5G, so the networks are very dense. You will see more radio sites come in for 5G than what we saw for 4G. And what that means is, going back to this slide, if for every radio site I'm doubling the power, in 5G, I'm also doubling the number of radio sites. Maybe not even doubling, maybe it is almost 4 or 5 times more radio sites than the 4G networks actually today have. So you will see things like this in the news, which is just coming out. saying 5G is an energy hogger. It's going to prompt energy consumption, and in the next 10 years, our energy demands are going to increase by about 160%, which is staggering. Today, we are not able to meet the energy demands of regular households or businesses. Cities, states, we experience regular load shedding. Some states have even worse conditions on their electricity demand, especially during summer. So when we add, and we know that we cannot be without these wireless networks, and when these wireless networks come around and put the number of radio sites in 5G, creating a dense network, it becomes imperative for us to understand how are we going to power these sites. Now, a lot of the what you're going to see in online, the parameters they use to describe what 5G is consuming, they would probably talk about watt per bit or watt per megabits per second. And of course, 5G has 1000x data capacity. So we can go up to 10 gig in 10 gigabits per second in 5G. These are ultra high speed networks. So if you start looking at, okay, this power consumption that I have here, what does it cost per megabits per second? Of course, we are pushing so much data rate through 5G. The numbers on your watt per bit will come down drastically. It will actually show that your 5G watt per bit consumption is much less than 4G. But the truth of the matter still remains that the power consumption is high. So you will see a lot of OEMs talk about, power is not a concern for us because the watt per bit is very low. But that is not completely true. Yes, the kind of data rates we are pushing through 5G, this computation makes it more economically feasible, that you're delivering more data for that amount of power that you're pulling to power these radio sites. However, the fact of the matter still remains that our current grids cannot support this demand. And so if I have to push in many radio sites in 5G, what does it need? What it needs is I need to get in and expand my power grid. And for per site, I need a grid expansion that would cost me about $2,800 US dollars. And so now when I look at the number of radio sites that have to be pushed in, this is a very low number that I have put in. If you look at China today, they are planning to push in 2.5 million tower sites in 5G. So even with 1 million tower sites, if I request a grid expansion to power these sites, I would have to end up spending about 2.8 billion US dollars to support grid expansion to bring in about 1 million sites into the country. And here in North America, our top operators are AT&T, Tier 1, T-Mobile, Verizon. These are some of the Tier 1 operators. Between themselves, they could reach this number very quickly. So now, as we are powering everybody's sites through the grid, through the power grid, through the national grid, it needs a overhaul to an extent that we have not understood really what is the impact of rolling out 5G on our power infrastructure. So this is an interesting thing to note, because this specific problem statement needs a lot more work than the amount of work that has been put in already. And I'll talk to you in the next few slides about how much has been done, but what has been done is minuscule. Now, when I look at today's total power consumption by telecom networks, and some of these numbers obviously are too big, so we go from 6 kilowatt per hour calculation of one site, and we said in 4G we are consuming 6 kilowatt per hour. Now, if I look at the total power consumption of telecom networks in general, They are consuming greater than 50 billion kilowatt hours today. And in terms of a carbon footprint, when we burn that much fossil fuel, it doesn't, so it could be nuclear power, or it could be fossil fuel power, water, hydropower, it could be solar, green power. However, we know the amount of green power is very low in percentage compared to fossil fuel generated power, nuclear generated power. When we look at the total power consumption, 50 billion kilowatt hours, the carbon emissions coming out of that consumption is nearly 13.6 billion kilograms. That's a lot of carbon emission. So if you're talking about putting cars, that the cars are polluting our environment, this should tell you that putting radio sites up, building 4G networks, building 5G networks, does not mean that you are not polluting the network. You are polluting the network big time. You are almost equivalent to having, millions of cars out on the roads. If 13.6 billion kilograms, if you put that into perspective, it's a big carbon footprint. Now with 5G, we are going to double that. So in the previous slide, we had seen that we are doubling our power consumption from 4G to 5G. So obviously, with that, if we are consuming 50 billion kilowatt hours now, tomorrow we are going to be consuming 100 billion kilowatt hours, double of this with 5G. And with that, we are going to double our carbon footprint, going from 13.6 billion kilograms to 27.2 billion kilograms. So this is a big alarming jump, almost double. And when climate experts talk about global warming, reducing our carbon emissions, becoming carbon neutral, here we are building a technology going from 4G to 5G, where we are doubling our carbon emissions by doing that. Now, this is a topic not many in the industry are going to discuss or even talk about, because this doesn't look very pretty. And that is one of the main reasons why I said I must talk about this issue, because this is what is needing to be solved first and foremost before we do anything else. We can talk about going 5G to 6G to 7G, but it is not happening until we solve this problem with power consumption on 5G. Now, several companies have come in and tried to make some changes for sustainable power generation. So we know our carbon footprint, our power consumption. They're looking to see how to make more efficient power generation ideas. These are mostly software-based, a lot of AI, battery-based lithium energy. So one of the very small initiatives, and this doesn't even need any technology to do this, is to make sure that it's one cabinet per site. Today, if there are many companies, like many operators, everyone, like Professor Rao said, there are three antennas, three towers up on the building. Every operator is going to push in their own cabinet, their own heating and cooling, their battery backups, diesel generators. But the idea here is, doesn't matter how many 5G radios are mounted on the tower, there's one cabinet implemented per site. So the power is required just for one cabinet, and it houses everyone's equipment in there. That's one very low hanging fruit. The second one is intelligent peak shaving, where when you look at what your peak demands are, and the grid knows what the grid's peak demands are, during those peak demands, the radio site equipment uses software where it decides that instead of pulling power from the grid, it is going to pull power from a lithium storage, basically a battery storage, during the time of the peak hours. So that's referred to as intelligent peak shaving. The next small initiative that has been launched is called intelligent voltage boosting. And this is very similar to peak shaving, where these are all software-driven solutions, where again, to boost voltage or to boost coverage, they are going to take some power from the grid, and they are going to introduce battery-based power in there, so that we don't overload the grid, but we constantly also charge our batteries, but also consume the batteries, very similar to some of the EV vehicles that have come onto the roads, where you can efficiently use batteries while you're using the fuel to drive your cars. You can use the grid power, but also use the battery at the same time. So basically, intermittently you use the grid, intermittently you use the battery lithium stored energy, not just for peak hours, but this is done as a continuous voltage boost. And then, of course, since we are now relying so much on battery energy, even to power radio sites, not just as backup. Most radio sites used to have batteries as backup earlier for when they lose power to the radio site. So they have a lot of companies are working on intelligent energy storage in this space to understand what are the best ways to store energy. The use of supercapacitors has come in today. Several operators like Etisalat and some others in the Middle East and the APAC area are experimenting with supercapacitor batteries. Now, the only issue with supercapacitor batteries is there are 6 manufacturers in the world overall, with probably a couple of them being in China. There was one in North America which was purchased by Tesla. So supercapacitors definitely are one of the areas with graphene that is being looked in for energy storage. But again, if you look at this, this doesn't really suggest something groundbreaking happening in terms of power generation ideas or power saving ideas for radio sites. So we want to see what else can be done. So one other idea has been implemented mainly by companies like Ericsson and Huawei, where they study the traffic envelope, and they look at how often a radio site actually is transmitting data. And so this top graph here actually belongs to a 4G network. On this graph, you'll see that data is not transmitted every second. Data is intermittently transmitted. That means there are gaps in between these data transmissions. And to create a little more precision, to save basically the power, they have implemented some power saving solutions on LTE networks, which is 4G networks today. Because they have found that there is a delay, there is an intermittent gap of 0.2 milliseconds as far as 4G is concerned, where the radio site is not, where the base station is not transmitting, and you can put it to sleep, just like your computers. If your computers are not being used, you can do a sleep mode on it. They have implemented sleep modes on these based on these radio sites, and that has produced savings in energy for LTE. However, if you notice, 5G as a technology itself, that's here down on this graph, has the 3GPP recommendations and specifications have tried to build 5G a little more efficiently. The problem here in LTE is it requires a lot of reference signals, synchronization signals. Those are constantly transmitted, whereas in the case of 5G, the requirement to do synchronization signals, reference signals have been taken away. What they do is they only transmit the data in a chunk of, say, 20 milliseconds. And then the rest of the time, the radio site doesn't need to be active. So again, the 5G technology, the way it's built is highly efficient in its technology itself. And so if we want to find how often can we put the radio site to sleep without consuming from the grid and hence reduce our power consumption, this is one of the recent ideas that has been implemented and tested today by Ericsson. Very recently, I think at the end of last year, 2021, they did a demo of this technology to show how much power reduction can be by just implementing a microsleep on the transmit side of things. Now, my next slide here shows the reduction in power. So if this is here, this is 4G. The blue bar is 4G. Without no sleep mode implemented, this is the power consumption on 4G. This is the power consumption on 5G as measured by the industry. So these measurements have been done by Ericsson. Excuse me. Now, if we implement sleep mode on these radio sites, like what I showed, looking for the small gaps where you're not transmitting, you can reduce your energy usage in LTE from 100% to about 54%. That means we have halved our energy usage here. Now, in the case of 5G, there's a drastic reduction in it. Excuse me. It goes all the way from 90% to close to about 28%, because we get more time to sleep in 5G versus in 4G. So just small ideas like this, when implemented, it can have a big impact on power consumption. So I would like to just wrap up very quickly my talk here. So you will eventually hear that there is a demand on 5G, on our power grids as 5G is implemented. But we have to find a way to break that energy curve. How do we bring it either to the same levels as 4G or maybe even below 4G? And that is where I think a lot of groundbreaking work still needs to happen. These are some small steps we are implementing in the industry today, where we use software to do energy saving. We build 5G with more precision, putting sleep modes on the radio sites. But what else can be done to break this energy curve? And with that, I end my talk here. And again, I thank you for the opportunity for me to bring this important topic and this important question to the industry, specifically your research community, to see that what else can be done. And I'm sure I heard your university is working, there are several departments in power related engineering. So these are good problem statements for you to be able to address. And with that, I end my talk here, and thank you very much for this opportunity. One other final thought I would like to leave you with is, I see a lot of people saying, these days there are a lot of women in engineering. I remember being in the university and I was in a class of 70 and there were 9 girls. So 9 girls in a class of 70. I'm sure now those numbers have improved considerably. However, when I look at my career, I never observed that I was a woman working in the industry. I only did my work. It just so happened that when others came by, they observed that a woman was working in the industry. As a woman engineer, it never occurs to me on a daily basis that I'm a woman and I am doing all this. I know that I'm working on something I'm very passionate about, and that's all I usually have in my thoughts while I'm working. But it is the others who come and they observe, oh, there is a woman working in the industry. So with that, I feel everyone has the opportunity to make a huge difference sometimes we do have to lay down our gender biases and just focus on the work needing to be done. And then the right recognition for others to recognize will happen on its own time. So with that, I thank you, and thank you everyone for this opportunity.
Thank you, madam, for giving such an enlightening and relevant talk on a topic that is very much applicable for the 5G wireless network application. If you consider the how to reduce the carbon footprint, because it is quite, it is very much essential for the society across the globe. So that is our duty, though we are developing the technology, but the challenge we are facing, how to, and how we have to help the society in return, that how we can do the, and also for the sustainability of this wireless network application. The research you highlighted, it's quite interesting, and you opened up many research challenges relevant to the power consumption of the 5G e-node base, and considering the future densification of the cellular network and the number of nodes in a particular area, the utilization, how to utilize or how to optimize the power is a very challenging task. So I hope all the participants are highly benefited with your talk. And
Yes, I
again,
hope
thank you.
inspired
Thank
a
you.
few people to think out of the box about a problem.
Yeah, it's very nice to interact with you in this forum and get
I
your
also want
industry
to
ideas
mention,
from you. What is
thank you,
going
thank you.
on in industry? We are academia people. We always work on advanced technologies, how to develop, but we are not aware fully of the industry challenges and implementation aspects. So this type of interaction with industry people will really help us to motivate further to take up challenging research ideas and solve the practical issues which we will be facing. So thank you once again, madam, for giving this talk and sparing your valuable time with us.
Thank you very much.
Yeah.
I just
So,
wanted to also
any
Madam, I want to
questions?
interrupt. Some questions is there, I hope, in the chat box.
Yes.
Okay.
So one question from the Bibhu Datto. So Mr. Bibhu Datto, so do you think the energy efficiency you are LLC, the enabler, be considered for energy efficiency? And also, do you think machine learning algorithm can be explored to learn the wireless environment and formulate the appropriate configurations for the same?
Yes, that's a very good question. Actually, that is the kind of work we are doing in Innovate 5G, where we are looking at network power consumption as one thing, but we want to know what is the application power consumption. When the application is running through the network, what is it using in the network, and how much power the network is putting in just to support the application. So to come from an application standpoint, looking from the outside in from the edge, we have been able to gather data in the network where we are trying to predict and extrapolate, what is the application power consumption from the network. In that case, the network requires a certain amount of energy to sustain its operations. Another is how much power is really needed by the application. So once we are able to create a profile for application power consumption, which is the first time we are actually doing this work, then we can see, the network, how much of this power is just used by the network itself, and where we can make some efficiencies there. So definitely for us to find application power consumption of the network, we're using machine learning algorithms We are using a lot of filters to understand how this data moves through the network, which components in the network does it hit, to precisely find the right calculations for power consumption there. And, no doubt there will be many such ideas to try and understand, but then we are also implementing features like low latency, high bandwidth. These are important features to implement. And we can't shy away from implementing those just because they are energy hoggers. But we have to find other ways to make the energy consumption more robust, more sustainable. So that I don't know if I could completely answer that question, but machine learning definitely is the answer for the moment, trying to understand how much energy is being consumed and creating models based on that.
So if any guest have any question, please raise your hand.
Can you? Hello.
Hi, Annapurna.
Thank you, madam. Hi, madam. Thank you, madam, for your wonderful talk. I just wanted to know that there is a trade-off between the network traffic, which is going exponentially, and thinking about the power consumption solutions for these networks, because it's not uniform everywhere, because there are industries, there are different sectors. So implementing something standard for these type of networks, which is varying from different deployment scenarios. So I think there will be a trade-off between all these applications. So what's your take on this, Mimo?
Yeah, so that's a very good question. What is the application? If it's a mission critical application like V2X, tomorrow we want our cars connected to these networks, and they're mission critical. They cannot lose connectivity to the network. The power consumption that's required by 5G is passed off to the application side. Then we can say this carbon footprint that we are creating on 5G is actually shared by the V2X industry, that is autonomous driving, right? So now the cars themselves are polluting the atmosphere, but now we are needing infrastructure that also has a carbon footprint. So we have to look at that. That's a very good comment, that we have to look at the type of application and how the problem compounds from there, right? Which is why, today, if you are watching Netflix, ordering an Uber, the carbon footprint is minuscule. If you go to augmented reality, maybe still not big, but the moment you step into V2X, long haul transportation that is connected to the network, and networks have to run all the time. In fact, you may not find many micro sleep instances because the data is going very back to back very fast. Then there is no energy efficiencies in the micro sleep solution, right? So depending on that application, and that's what we are trying to do at Innovate 5G, is to try and understand what is the profile of the power consumption given a specific application. So today we have just started that work, and that work needs a lot of work. It needs a lot of participation. It needs a lot of data from the industry. Today, we are just looking at the tip of the iceberg and seeing what would be the characteristic and how would we predict the energy usage even in the future. So that's part of the measurement and the prediction, but still the problem remains, how do we conserve energy here?
Yeah, that's right. Thank you for your
Thanks,
answer.
Annapurna. So I actually wanted to quickly mention, I was born and brought up in Calcutta. So,
Nice
so
to know.
obviously, NIT Roorkela is something very close to.
Yeah, it's
close to
5
my
hours,
heart.
5.5 hours. Yeah.
Yes, and I especially heard a lot of people speaking Bengali, so I could understand. I've been, actually, my husband is a Bengali, so my last name is really Mukherjee, but my maiden name is Varma.
Okay, that's nice. Before concluding, I request Professor Suman Kumar De, my colleague and co-coordinator for this program, to offer vote of thanks from our behalf. Thank you once again for giving me an opportunity to address. I wish all of you a very, very happy Holi. So Professor Suman De, please.
Okay, thank you, madam. Good evening, all present here. Thank you is such a prayer that cannot be seen or touched. It must be felt by the heart. I feel honored and privileged to get the opportunity to propose a vote of thanks on this special occasions. I would like to thank all the honorable delegates who bless us with their presence. On behalf of the organizing committee, I convey my deep regards and gratitude to our Honorable Director, Professor K. Uma Maheshwar Rao sir, for his valuable time. I want to thank to our beloved head of the department and chairperson Gauti, Professor Deepti Patra, for her constant motivations and support that radiated a source of energy within us. I also thank to the Dean Srik, Professor Shantanu Paria, for giving all the necessary administrative approval for organizing the webinar. I would also like to thank Professor Iti Shaha Misra, Chair-elect Kolkata IEEE Kolkata sections, and Professor K.K. Mahapatro, Chair IEEE Raurkela subsection, for their support to organize the webinar. We will fortunate today to have Ms. Rashmi Varma, President and CTO, Innovate 5G Incorporations USA, who has delivered a nice keynote address about sustainable power consumption in 5G networks. Thank you, Madam, for accepting our invitation in a short notice and giving a valuable talk from the USA in the early hours of day. I am very much thankful to all our faculty colleagues and non-teaching staff members who stand by us and motivated us. The event of this dimension cannot happen overnight. The wheel start rolling months in advance. We have been fortunate enough to be backed by a team of very motivated and dedicated students volunteers. I want to thank everyone for their involvement and willingness to take on these completions of tasks beyond their comfort zones. I express my gratitude to all the eminent speakers from industry, academia for their willingness to share their expertise in this webinar. I am very much thankful to the DST Gati Vice Kiran divisions for sponsoring the webinar. I am also very much grateful to the IEEE Kolkata section for being the technical co-sponsor and IEEE Raurkela subsection for support. Finally, I would like to thank all the participants from industry and academia for taking interest in this 5 days webinar and hope for their full cooperation for making this event successful. We thank you all for being with us today. Stay safe during this COVID pandemic and enjoy the webinar from tomorrow afternoon onwards. I wish you all a happy Holi. Good night. Thank you, all of you.
So